Thank you so much, Shreya. Hi, everyone. My name is Rachel Dzombak, and I'm really excited to be here with you today to talk about one of my favorite topics, which is all about how to embrace complexity and leverage methods from design and innovation in order to do so. Quickly, a background on me. I'm currently on the faculty at Carnegie Mellon University, where I teach innovation across design, business, computer science, and engineering. I also run my own consultancy, helping folks in the public sector think about how they can leverage design and innovation to solve problems that matter. So let's jump in to think a little bit about why we need new methods, new ways of addressing problems. I'm going to start by contrasting different types of problems. So oftentimes when we talk about problems, we don't add a lot of nuance, but there's actually multiple types, multiple flavors of problems. So complicated problems are ones that are, of course, hard to solve, but complicated problems are ones that have a series of variables that ultimately can be broken down, and you can understand the relationships between those variables. And so this is what a lot of us are taught in school to solve, complicated problems. A great example of a complicated problem is a combustion engine. Things that are complicated, they have many parts, but those parts are joined to the next in specific knowable ways. And so if something fails, a person who has knowledge of the system, knowledge of the relationships, can go back, can understand what's happening in that relationship, fix the problem, and move forward. Because these systems are inherently deterministic, they're predictable. So we can understand where and how to intervene to get to the outcome that we want. In contrast, complex problems are a little bit different. Complexity occurs when the number of interactions grows highly numerous. And so that introduces interdependencies and relationships that ultimately can't be predicted. They can't be broken down. And that's because the variables in complex problems change over time. They're dynamic. And so it'd be impossible to understand and map or define every single relationship that exists in a complex system. That's what leads to events being unpredictable. That's what leads to this effect of complex systems being what we call emergent. The COVID-19 pandemic was a great example of a complex system. We could have never predicted how a virus could spread so quickly, or the number of far-reaching effects on our social, our political, our economic system. There was no way of defining all of the interrelationships that exist. And so when we're dealing with complicated versus complex problems, we need a different set of toolkits. And what makes this challenging today is that we're seeing a lot of complex problems coming to the surface. We're seeing this emergence of complex multi-stakeholder problems, but we haven't yet improved our methods of problem solving. So we have this big gap between our ability to solve complex problems and the number of complex problems that we're faced with as a society. So what's stopping us? Why is it so hard to address these complex systems? If we look into neurological research into the way that our brains function, oftentimes when we are trying to problem solve, we are looking at stimulus and outcome. We're looking at trial and error, cause and effect. And we're relying on a mode of thinking called incremental learning. We're trying to make sense of something, draw conclusions, and move forward. It's the scientific method in action, if you will. But what happens and what neurological research has shown is that when uncertainty is high, we as human beings move out of our process of incremental learning, and instead we jump into what's known as one-shot learning. And that's based on our survival instincts. We're trying to make sense of situations that feel uncomfortable very quickly. And in those situations, we're often drawing conclusions, which might be based less on what we're actually seeing and more on just trying to figure out the solution very quickly. And so when uncertainty is high, we need to pay and we're in this one-shot learning mode, we need to pay a lot of attention to between the stimulus and outcome in order to learn, in order to do sense-making well. And that means we have to override the way our brains are naturally function. That means we have to stop ourselves from bringing our biases, from drawing on the assumptions that we've made with probably inaccurate information. And that's very hard to do. And so that's where design and innovation methods can come in to help us be more critical of what's happening when uncertainty is high. And it's really important to do so because right now, these complex problems are intersecting across so many sectors, so many areas. I don't think there's a single business that knows how to solve every problem that it's faced with today. And we're faced with, and we as engineers, as product designers, as systems engineers, we are challenged with thinking about how we design systems of the future that accommodate both technology and people. If we focus on just one dimension or the other, we won't address the whole set of facts in one moment. Take for example, the introduction of autonomous vehicles. If we're introducing autonomous vehicles, it doesn't just affect the technology itself, it affects so many other things in our society. It could affect insurance patterns, it could affect how people move, our traffic patterns, it could affect all of these different dimensions. And so we have to take all of that complexity into account when we're thinking about what it is that we're creating. And we have to be intentional. There's a responsibility to think about what's the future that we actually want to create. How are we bringing together these disparate, messy parts in a way that makes sense, that leads to the outcomes that we want to have? For all of those reasons, it's why we need to be thinking about how to embrace complexity with a high degree of intentionality, because that's what will help ensure that we are going to create systems of the future that actually lead to the benefits that we're interested in. So of course, the fields of design thinking and innovation have been around for a long time now, but I think they've never been more important because they help us to figure out what steps we can take and have agency when faced with complex problems. Innovation methods from innovation, they help us address that issue of how to make sure we are having additional focus to learn when we are faced with high degrees of uncertainty, because they impose order on our perceptions, our experiences, and our expectations. They help us to challenge our own assumptions or the biases that we're jumping to in our head. Some of the questions that might come up when we are leveraging innovation methods are, what are the viewpoints I'm bringing into this? What aren't I seeing in this space that is salient? What additional outcomes, what unintended consequences could be emerging from this system that I might not be thinking of? What are we learning from this? How do we move forward? Design methods and innovation methods help us to figure out the answers to those questions. So ultimately, we can learn about what it is that we're seeing and keep taking action in order to drive the change that we want to have. So I'm going to quickly talk about 3 key strategies that can help us in leveraging design and innovation to embrace complexity and to address these multi-stakeholder problems that we're faced with today. So the first is all about grounding in process and bringing your team along with you. So I draw on an innovation process that's based in experiential learning theory. As we go through that incremental learning phase, we are toggling between 2 different sets of axes. We are toggling between being in the abstract space, being in our heads, coming up with ideas, and being in concrete space, dropping into the real world and seeing how our ideas play out. We also toggle between analysis, asking questions of why, and synthesis, asking questions of how. And so if you look at these 2 axes, it forms 4 quadrants. On the left-hand side, it sets us up for the problem framing dimensions of the innovation process. So in the bottom left-hand corner, we're in the phase of observe and notice. This is asking questions of why, but deeply looking at the real world. This is where ethnographic interviews or observation would come in, trying to understand what's the current state of the problem. But then we have to step back and look at the patterns. That's where we jump up into frame and reframe, and we think about, what are we seeing across the interviews? What did we hear? What does this mean? What's the deeper meaning behind the data that's coming in for us at any given time? Where should we intervene? Where should we address this problem space in some way? On the right-hand side, the quadrant set up the problem-solving process. In that abstract space, that's your classic brainstorming of imagine and design. What are all of the ways we could address this problem before you drop into concrete space and say, okay, let's try it. Let's start to experiment a little bit. And all sorts of innovation processes could be mapped to the same 2x2 I've presented here, because they're all learning processes. So design thinking, critical thinking, lean, total quality management. It's just a matter of how much time you're spending in each of these different quadrants. So in some ways, it's arbitrary what process you're following. But when the problem that you're working on is complex and feels very overwhelming, it's important to focus on, well, what are the pieces that I can control? And that's where process comes in. Grounding in process helps us as designers, as engineers, to not get too overwhelmed with the problem and just not think, well, this is too big, I just can't work on it. It gives us a roadmap to say, here are the set of activities I can do to start making sense, to start unpacking a little bit about what's going on in this complex system. The other piece of this that's super important that I mentioned is that making sure that you're aware of where you are in process and where your team is. Because problems we're solving today, these complex problems, they can't be solved by a single individual or a single discipline. They require a diverse team. And oftentimes, one of the main sources of team conflict is actually that people are in different places in the process. Someone is still collecting data while somebody else is already jumping to solutions and brainstorming. So as you're trying to lead a team into complexity, you have to make sure that the team is aligned on where you are in that process at a given time. So the next element that is critically important is to think about being willing to examine the whole system. That it's easy to, or desirable to think about, how can we simplify? How can we draw a tight bounding box around what it is that we're doing? But instead, that often is insufficient for the types of problems that we're trying to solve. And teams and leaders have to be willing to see the multiple dimensions of the problem that they're working on at a given time. So let's go back to our example of autonomous vehicles here for a second. So if we're introducing autonomous vehicles and I said, you know what, I'm just going to focus on the sensors. I'm going to focus on how can I optimize the sensors that we're using to ensure that we have high visibility and are able to gather the information that we need. Well, that is going to limit so much of the other dimensions of the problem. I have to start thinking about, okay, what is the supply chain issues that might intersect with my ability to gather and manufacture the technology. I have to think about, what's the regulatory framework? Am I allowed to deploy autonomous vehicles in the geographic region that I'm in? There's all sorts of these compounding dimensions. When I used this example once in class, a student said to me, well, what about organ donations? How will autonomous vehicles affect that? And I thought, organ donations, huh? But they went on to say that, of course, car accidents are one of the leading sources of organ donations, at least in the United States. And so there's a hypothesis that as we introduce autonomous vehicles, that will increase car safety and lead to a lower number of vehicle accidents. Therefore, that might diminish the source of organ donations. Now, of course, if I'm the engineer designing the sensors, I don't necessarily need to also be working on the organ donation challenge, but I need to be able to pop my head up to understand these far-reaching effects because it will drive impact on what it is that I'm trying to do in small ways. And I love this quote that I'll share here, which is that one cannot understand a part of a system without having at least a rudimentary understanding of the whole. I think that it would be great if we could just focus on one dimension, but unfortunately, that's just not practical for the types of problems that we're addressing here. And it's the responsibility of teams to be thinking about these far-reaching effects and be willing to go forward and see these multiple dimensions if they want to drive the broader change. And this quote comes from a book that was focused on the Apollo missions. And really, it was also speaking to the skill sets that a team needs. That when they were designing the Apollo mission, they said, we don't want to have just experts in one specific area. We need folks that can do both, that can have deep expertise, but then can also learn across multiple dimensions because of how critical they all are to the success of the mission overall. They wanted to fuse generalized awareness with specialized expertise. And that's a core strategy when you are thinking about the teams you're assembling to address complexity also. It's not that one person needs to have all of the rudimentary understanding of the whole, but it's more so about how can I pay attention and ensure that across the team, we have knowledge of this broader system. The other way I like to describe this is it's thinking about moving between the dance floor and the balcony, where if you're on the dance floor, you are deep into the action. You're looking at what are people wearing? How are they moving? What's the conversation that's happening next to me? Or what's the behavior dynamics between a few individuals? And that gives you one perspective. But if you run up to the balcony, if you're looking at the dance floor from a level up, you see things entirely differently. You instead see, okay, where are people congregating? Is the music too loud and people are staying away from the DJ? Is there a line at the drink station that's impacting people's ability to move? Is no one on the dance floor for some reason? You're able to see that in a different way. And so I think that's the opportunity today, is when you're designing that one component of a system, when you're focused on the sensors, for example, that is being on the dance floor. You're focused on that individual element. But it's a key skill, especially of leaders, to over time run up to the balcony and say, what are the broader trends and patterns that are happening here that affect what it is that we're trying to create? The last principle that I'll share is to look for creative tensions and hold multiple truths. And this builds on the prior section, but I think it will say it a little bit more explicitly. This is a classic image here, and oftentimes has been the source of debate to say, what do we see in this image? Is it two faces? Is it a vase? And really the answer is both. It depends on where your eyes focus at different times. You might see the faces, you might see the vase, you might go back and forth. Often we want one answer. We want to say it's either a vase or it's faces. But what happens if we embrace the fact that there really is both? These creative tensions, as I call them, are an opportunity to help us hold complexity in a different way, as well as unlock new opportunities. Within design, we're always thinking about how can we use constraints to fuel our work in new ways. And so think about this as, if we have these creative tensions, that becomes a whole new set of constraints that could unlock us to think about ideas, think about courses of actions that we might not have previously. If we're optimizing for quick wins or systemic change, that could be two totally different sets of solutions. But what if we bring those together? What if we say we're optimizing for both quick wins and systemic change? What could that lead to? Often we think there's a disconnect between being collaborative and moving fast. But what if we were trying to do both? How could that unlock new behaviors across our teams, across our organizations? And again, I think this is a willingness issue. We often want to pick, the folks that we manage, the folks we work with, want us to pick to simplify. And if we want to actually drive broader change, we typically have to be on both sides of this and take this yes and mindset, that it's not necessarily one or the other, but that we're entertaining both of these options at once. And that's the other piece of this to look at, is that there's not one right answer to the types of complex problems that we're working on. It's not saying that one of these pathways, path B, is definitely the best one that we should take. When we're dealing with complex systems, think about how I define the difference between complicated and complex problems. With complexity, we're thinking about probing, we're thinking about experimenting, we're thinking about taking the pulse of the system, because realistically, the system is changing as we're working on it. So instead of saying, okay, we as a team, we're going to solely focus on path B to get up to this mountain, we're going to say, what could we learn about all of the paths? Why would they be different and beneficial to us in different situations? Is there necessarily a right or wrong, or is it just trying one, seeing what it leads to? Because the truth is, in complex systems, there's multiple paths to impact. There's multiple ways of working. And this is what I think leads to the fundamental mindset shift that's needed. So often, especially of those of us with a technology background, I have 3 degrees in engineering. I was really taught to think about to break things down into the component parts and see what they lead to. Think about, how can I optimize the individual elements that I'm working with to get to that one fixed outcome. But I think the opportunity when dealing with complexity is to think about, how can I articulate the outcome that I want to see? What is that end state? And then work backwards, reverse engineer, and embrace that experimentalism to understand, how can I play with these different elements? What are the combination of variables? What are the different experiments I should run? What are the multiple prototypes that I could create? What's the data that I need to bring together to get to that desired outcome? And often the hardest part is to think about, what could that desired outcome look like? What actually do we want to see in the world, which a lot of times doesn't exist in the present state. So it requires that creativity in many ways. And it's completely worth it to do so because of the types of problems that we're faced with today. Because complex problems are sitting here, there's a lot of work to be done. And so in conclusion, the 3 ways I really think about embracing complexity is to ground in process, make sure that you know where you are in a given process and you're aligning your team to that process as well. to be willing to consider the system, to see the individual human experiences and behaviors, but also to take a look at the broader patterns and behaviors that are emerging over time, and to think about holding creative tensions, that it's not an either or world that we're living in, but it's often a both and that doesn't need to be intimidating. It can unlock new opportunities of innovation if we're willing to go there in our process. Thanks so much for your time and listening today, and back to you, Shreya.
For more interesting content, like, comment, and subscribe to our NASSCOM YouTube channel.